it's a little labyrinth, guys, behind this huge organization of sessions. So thank you. Thanks to the speaker for being here, and thanks, of course, to the audience and participant to join this session. So I'm Monica Rossi. I'm the host of this session, and I'm going to introduce you this session on designing for the environment using lean product and process development to lower carbon emission and other sustainability concerns. Very important topic presented by Katrina, senior lean coach at the Lean Enterprise Institute, as well as president of Katrina Apple Consulting. And she has a PhD on industrial and operation engineering in the University of Michigan. Together with Katrina, we have Daniel Cooper, who is an assistant professor in mechanical engineering in the University of Michigan, and his research focus on making impactful contribution to manufacturing and sustainability. And he has PhD as well as bachelor degree and Master of Science in the University of Cambridge. So together with us, let's welcome Katrina and Daniel. And please, guys, the stage is yours. I will be moderating the questions. Katrina, just a question before we start. And Daniel, would you like me to interrupt you in case we have questions in the chat? So I will interrupt and read the questions for you. Or would you rather wait at the end of your presentation to collect question and answer session?
Please go ahead and interrupt. We probably won't get to the end if there's a lot of questions to interrupt, but that's okay, because I think it's better to address people's questions when they have them on the content that we share.
Great, thank you very much. So really, questions. Okay, together with me is Gianpaolo, is my, let's say, research assistant. We work together in the University in Milan, so I asked him to join me in case the conversation will last longer and I will have to jump to the next session because I'm hosting a bunch of sessions today, but you are covered. So thank you, Daniel and Katrina, the stage is yours.
Thank you, Monica.
Thank you. Okay, well, good morning, good afternoon, good evening to everyone, depending on where you are in the world. To begin, let's look at the role of manufacturing and production when it comes to environmental impacts. So focusing on the biggest global issue of today, climate change and greenhouse gas emissions, these pie charts show the contribution of different sectors to global annual carbon dioxide emissions. The pie chart on the left here shows that emissions can be split roughly one third between buildings, transport, and industry. So a third of emissions coming from making stuff and 2/3 coming from using the stuff, the products that we have made in industry. Taking that industry segment, which is huge, it's a third of the pie, taking that industry segment and expanding it out to the pie chart on the right-hand side, we can see that metal manufacturing, for example, accounts for around 10% of global industry emissions. So that's taking metal material that's already been made and converting it into products. But that pie chart on the right-hand side also shows that over 50% of industry emissions come from making just 5 key materials: steel, cement, paper, plastic, and aluminum. What does this mean for manufacturing? If you could click on, please, Katrina. Well, there are certainly opportunities to improve energy efficiency in manufacturing, and they are worth pursuing. As we can see, energy in metal manufacturing alone accounts for 10% of industry requirements. But we also need to work on improving our material efficiency. We are already incredibly efficient in how we make these key engineering materials, and we are approaching thermodynamic limits, efficiency limits in many cases. So if we want to drastically cut emissions, we are going to have to get a lot better and a lot more efficient at how we use the materials that we produce, and there's certainly scope for improvement there. So for example, around 25% of all the steel we make and 40% of all the aluminum we make globally is scrapped along the manufacturing supply chain before reaching a product and ultimately use with a customer. You can click on, please. So what's the role of engineering design in all this? Well, just as with product lifecycle costs, it is the decisions made during the design stage that have a lasting impact on the energy requirements and emissions released from production, and also the environmental impacts of using and then disposing of the product. So, for example, design determines the potential for component reuse, product remanufacturing, and material recycling at product end of life. Now, traditionally, it's the use phase when we are operating the product, when we are, for example, driving our car. That is traditionally where most of the emissions and the environmental impacts occur. But the efficiency of many products has been improving dramatically in recent years, that use phase. And that increases both the relative and absolute importance of production and manufacturing emissions. Because these use phase efficiency improvements are often bought, if you like, at the expense of more emissions intensive production. So just taking, for example, an electric car or a vehicle with a lightweight aluminum or composite body, that's much more emissions intensive to produce than a traditional mild steel an internal combustion engine alternative. Next slide, please. So designers need to increasingly consider the ramifications of their designs on energy and material efficiency in manufacturing. This is a flowchart adapted from Horton and Allwood, who are focusing on the automotive industry, and highlights that material efficiency is considered to some extent within manufacturing after the product design has already been set. And at that point, there's very limited scope for improvement. But in that design stage, there is actually very little, if any, formal consideration of material efficiency. And this is the same across many different industries, not just automotive. Next slide, please. So what can we do? Well, there are many eco-design tools available, and many of these are in the form of checklists, life cycle assessment tools, function deployment tools. And most of these tools, though, do not emphasize that important link between design decisions and manufacturing constraints and the environmental impact from manufacturing. And so in this presentation, we are really going to echo the recommendations of Sutherland et al. in their recent paper on industrial sustainability, and emphasize the need to exercise systems thinking across the product lifecycle to anticipate and avoid creating environmental problems by addressing and eliminating the root cause of these problems at their source. And this is really a call to follow the teaching of Edward Deming with a process control-like approach to modify or replace industrial processes to consume fewer resources and produce fewer wastes.
And so building off of that and following that approach of following Deming's teaching, that paper emphasized following one of his principles, but all 14 of his principles really fit together. And if building off of that's, where Toyota started a lot of their learning on LPPD. And in the decades of research that have been done on LPPD since, we've now distilled down to these 6 principles that Jim Morgan introduced earlier today. These are the current guiding principles that we're focusing on, that a lot of the research is built to. And so that really is that focusing on putting people first. It's the people that bring the heart and soul to development, and they're the ones ultimately making the decisions and do all the work to design products and design the manufacturing systems that we want to make as efficient as possible. Understanding before executing. If we understand upfront what the product needs to be, we can then execute with speed and precision. Also understanding that upfront what that total life cycle impact for sustainability is. We want too often those decisions are made without understanding fully. Synchronizing workflow. So if we understand how our work fits together, we can get the right knowledge at the right time to the people making those decisions that are going to impact the ultimate sustainability of the system. Developing products is a team sport. No product is ever developed in isolation. It's a team that works together. And so how can we create the systems and structure to enable teams to be effective working together? Building and learning and knowledge reuse. So first of all, how can we learn as fast as possible in learning? But then the real competitive advantage is how do we not relearn on every project and capture that knowledge? How do we capture the sustainable methods we're using on this project and use them on future projects? And then ultimately designing the entire value stream. And from that value stream, the way that we're thinking about it is that entire life cycle. So it's that upfront in doing design. How do we make sure that we're designing a sustainable entire value stream from designing it to how we make it, to how we use it, to ultimately what's the end of the life of that product.
Katrina.
During industrial state. Yes, Monica.
Yeah, we have a question about this, about the life cycle, about the later phases. What about so Unai is asking, what about emissions due to logistic operations?
What do you have, Katrina?
Go ahead, Dan.
Yeah, I of course I'm going to respond in a broad brush and a generalization here, rather than a specific product. But generally speaking, logistics, it's certainly important, but is overwhelmed by the material and manufacturing emissions. So what we found when we've looked at this is logistics certainly are not insignificant, but it has a bigger, if you like, hit in terms of costs than it does in terms of environment. So naturally, people perhaps drift to looking at logistics because it can be great to reduce emissions and it will be potentially a big impact on cost savings. But in terms of absolute impact, materials and manufacturing typically dominate over logistics.
Thank you, Dan. And so then we've got a couple case studies that we've analyzed on looking at how LPB delivered environmental benefits. One of the things with both of these case studies is neither one of them had their business motivations being about environmental sustainability, but there are some great benefits where as Dan said, if we want to really focus on material utilization and energy utilization, both of those things are also going to save money aspect. And so from that standpoint, if we can get a alignment with other business motivations, it makes it easier to focus on sustainability, but also these methods can be used with that primary goal being sustainability as well. So these two case studies, one of them was the Ford F-150, and that was transitioning to an aluminum, all aluminum, which is very expensive material. So focusing on good material utilization was critical for that to be a successful project. And that was building off of years of work on focusing on material utilization. And then a subsea oil extraction process, where a lot of this focus was on that, how to make things smaller and focus on a smaller size and smaller footprint to be more efficient. But that also is going to impact the logistics, and just having things be smaller is going to be lower emissions in that transporting aspect and lower material utilization, less material being used as well. And so both of these case examples used LPPD and some of the strategies they used to deliver that change, including setting really clearly defined targets, having really good communication using OBEAs was pretty consistent across both organizations, having very deep collaboration with supply chain. In the case of the F-150, being able to make sure that they could recycle the aluminum at in how they've set up the entire system was really key. With the supply chain, both focused on optimal standard architectures. In the case of the F-150, really focusing on that fixed and flexible approach on only really innovating that stuff that the customers would see, but then having a lot of the inner body panels be fixed and optimal material utilization with the infrastructure. In the case of the Technip FMC Subsea 2.0, that was all focused around having standard architecture. The entire program was, and so that led to them being able to really focus on making things smaller with better material utilization, really having technical excellence to deliver these engineering challenges and how they educated people on these principles, and then how they effectively manage trade-offs, because there's always going to be trade-offs. And so what it really comes down to is how do you set yourself up for success early in the project to be able to manage those trade-offs and work effectively together as a team.
So based on these sort of initial case study findings, we hosted a workshop at the AME conference in Chicago 2 years ago in 2019. And that was attended by around 26 different industry representatives. And after presenting on these case studies, the attendees split up into small groups and answered questions around what are the environmental impacts in your manufacturing operations? What are the opportunities to improve the environmental impact and improve your bottom line? And how can potentially lean product and process development help to deliver these benefits? And so what we found in that session is that participants in upstream industry, for example, oil and gas and material production, glass manufacturing, for example, they identified energy waste and energy efficiency as primary targets for reduced greenhouse gas emissions. So, for example, reduced flaring, furnace heat recovery from furnaces used in material production. Whereas downstream manufacturers, essentially after stuff had solidified, if you like, the material had already been made, they really identified material savings, recycling and remanufacturing as the primary opportunities for significant environmental benefits. Several of the companies, for example, an oil and gas company at the workshop, not Technique FMC in this case, reported that their projects were unnecessarily bespoke, which perhaps it's not immediately intuitive, but because they were unnecessarily customized, it meant that the company actually had very little time to develop optimized energy and material efficiency designs. So there is greater potential for greater standardization and only changing where the greatest value is being provided. Another common theme across the companies was the need for tangible engineering targets that act as environmental key performance indicators. These were missing from most of the organizations at the workshop. In contrast, the Ford and Technique FMC case studies reveal the use and benefit of KPIs such as material utilization or part weight, in which those cases also had very clear environmental benefits. Other common themes at the workshop included the opportunity for higher material utilization. So, for example, opportunities in this space were identified by card manufacturers, PCB manufacturers, metal fabricators, and healthcare. And so greater understanding and collaboration between the design and manufacturing teams was seen as critical to actually deliver that material utilization, and greater use of design guides in order to effectively utilize the knowledge which is within the company, but is perhaps quite disparate and locked away in certain people's heads. Trying to get that out to benefit the entire organization was seen as important. Next slide, please. So we have summarized our findings from the case studies and that previous AME workshop in a conference paper. You can see the citation at the bottom of this slide. And this was presented at the ASME Design for Manufacturing and Lifecycle Conference earlier this summer. And in that paper, we summarize our findings and then focus on the need for translating environmental aspiration into concrete strategies. So LPPD, of course, in itself, it's agnostic to environmental sustainability, but it is a system that, when implemented correctly, can efficiently cut waste and deliver on organizational objectives. And those objectives, of course, need to be aligned with reducing environmental impacts for this to work. By the way, if you would like a free copy of the paper, then please do reach out to either Katrina or I. Our email address is, I believe, on the first slide. And I'll also put my email address in the chat. So feel free to contact me about that.
Sorry, Daniel, thank you very much for this offer. And I invite everybody to drop you a message to get the paper. Nicola is asking, how could we account or measure the impact on sustainability during the LPPD? How can I then spread it during its useful life?
I think, Katrina, is that essentially what you're about to address?
I think so. I think some of that, I'd say that this is probably the best slide to answer that question, is that if I'm understanding the question right, is that you really want to look at the entire life cycle across the product. And so that is across its use phase. So with the LPPD, like principles, it's the decisions we make in design that are going to ultimately impact so much of the sustainability across that life cycle. And so that really starts with understanding, with a life cycle assessment, to understand that use phase, understand the end of use, understand the make phase. And then from that, we can use our knowledge of that understanding before then when we execute the development, being conscious of those impacts and making decisions that have lower emissions or other sustainability concerns. upfront in design, because there's so many things that we can't, once the design's been made, it's not easy to go back and change. If you've designed in really high carbon emissions, there are some things you can do to lower it after the fact, but ultimately a lot of those are baked in and you can't reduce them until you redesign the product on the next design. And so that really focusing on that, understanding the impact up front so that you're making decisions that impact across the life cycle.
Great. Well, I think I'll hand back over to Katrina. I think now you are really going to talk in more detail about how to use LPPD to translate sort of environmental aspirations into strategies. So I'll hand over to you, Katrina.
Thank you, Dan. And so just focus on these guiding principles. So there's lots of tools that can be used, as Dan noted, but we really want to focus on that, looking at LPPD as a holistic system. What are the things that we can do to create the conditions to design for sustainability across that entire life cycle? And so, and those will fit those tools into as we think about all of these guiding principles. And so that first one is just really that putting people first. And so a key part here is that you get better performance when you put people first. So Daniel Pink summarized decades of research on human behavior and then the results. And basically, to get the best performance from people, they need to be intrinsically motivated, which is great because it's also more rewarding for them. So it's a win-win for the individual and for the business. And this is a lot of the intent when we talk about putting people first, is we want to create that conditions to enable people to perform their best and be satisfied. So the three things people need is purpose, autonomy, and mastery. And so purpose is really, what is the value of my work? Autonomy is having some control over your work, and mastery is about how do you improve your skills. And Lean can deliver on all of these if we're conscious about it. So really, as we talk about the other principles, and in anytime you're thinking about any Lean practice, whether it's to promote sustainability or otherwise, just think about how does that enable people? Because you need to be thinking consciously about how the people aspects of any Lean practice or principle and how you're enabling that. So for the purpose, you can really deliver with the helping people see how their work fits together to help the organization. For sustainability experts, creating a system that enables their expertise to get used up front and understood throughout the design and the development is going to help provide purpose to them. Creating the conditions to have that knowledge on how to design things that are more sustainable for everyone on the team is going to be helpful for their purpose. And then the understanding before you execute. So some of this is that understanding what those impacts are and what the decisions are made that have the different sustainability impacts, but then also making sure that as we're defining what the product is, that we're making sure that that's done cross-functionally in the study phase of development before we execute, and then capturing that in the concept paper to really deliver as the vision and the aligning document for the development. And so it's that, just want to make sure that sustainability is part of those upfront conversations. There are sustainability experts within a lot of organizations, and they just often aren't involved as early in design as they should be to have the biggest impact. And then from that, once we understand what those decisions are that have the biggest impact, we want to make sure that we synchronize our work and understand that decision flow and who needs to be involved in those decisions and with what knowledge to minimize the carbon footprint or whatever you're trying to achieve, whatever objective it is. How do you make sure that you're understand the impact of those decisions, and then get the right people and align their work, synchronize their work so that decisions are made consciously, because too many decisions are made unconsciously because we didn't understand the hierarchy and the flow of decisions within our organization. And so this is that we really want to make sure that we bring sustainability into those upfront conversations and get their work aligned. And then once that's done, that's really setting the program up. All of that should be up front in that study phase. And then how can we execute going forward? And so development is a team sport. How do we make sure we're creating that conditions using OBEA, aligning our work, once we've set our targets, creating our paths to meet those targets through glide paths, and making sure that we're just getting aligned and setting those conditions to work together as a team. And then how do we build in our learning and knowledge reuse? And so some of this is going to be, how do we learn as fast when we've identified what decisions we need to make for sustainability aspects, then how do we make sure that we can learn the information we need as fast as possible. But once we've learned it, how do we build it into our knowledge systems in a way that's usable for future projects so that we're not relearning it on going forward? And making sure that we've got in that design guides, when we've got focus on, different material aspects, like making sure that there's sustainability information in there. And then ultimately it's designing that entire value stream. So we start with that life cycle analysis to understand the impacts. Is those decisions that are made in design. This graphic here is focused on cost, but the same thing's true for sustainability, in that it's upfront decisions you make are going to have that impact on the make phase, the use phase, and end of life, and making sure that we're just thinking that holistically through. And then in that continuing research we're doing is really focused on that, starting with that understanding the impact of our designs on a current design and then laying out those decisions and synchronizing the work, getting the right expertise involved to make the best decisions, and using lean product process development guiding principles and practices to enable the team to work together effectively to design sustainable value streams. Are there any other questions? Thank you for attending our session today.
Thank you, Katrina and Daniel. So Monica had to jump out to the other session. So if you have any question, please write them in the chat or in the dedicated Q&A section. So we have a question from Jim Morgan. How do we get more companies to care about these and engage?
Thank you, Jim, for that question. I don't know. It's a great question. And I think, some of our intent is to just raise awareness of it. And any company that wants to engage, we would love to talk to and discuss further. Does anyone in this session have an answer to that question? Go ahead, Dan.
Yeah, I mean, it's, I was just going to say, I suppose some of it is cultural and some of it is, if you like, practical too. So, I mean, I do think that the people who are now graduating from universities are much more aware than perhaps previous generations of these issues, but also just from a sort of practical point of view, as we move towards addressing these issues as a planet and also as a nation, and administrations put in, climate change mitigation policies, it's probably going to start aligning more and more with your bottom line. So, we've already said, if you can save material, if you can save energy, then obviously you can save money. Well, as these policies come in, which emphasize saving emissions, it could be even save even more money because of things like carbon taxes. So I think there's both a practical and a cultural side to hopefully increasing participation.
Okay, thank you very much. I don't see any other question. So yeah, there's another question. Are there levels of difficulty in implementing each of the principles?
Yes and no. I want to say it's levels of difficulty on the principles, but there certainly are levels of difficulty on the practices that you would use. So these are guiding principles, and then within all the principles, there's different practices that help utilize those. So in terms of that build-in learning and knowledge reuse, focusing on methods to learn rapidly is, I'd say, level one. And that really is when you need to learn something, really focusing on what is the cheapest, fastest way I can learn this. And an advanced level of that would be knowledge reuse, because to be able to effectively reuse knowledge, you need to think about how will this be used in the future? How do we capture it in a way that it can be reused? And how do we build it into our system of how we're designing products so that it's easy to reuse? So that is, I like to think about a lot of the LPPD practices in terms of their using analogies with running. So I'd say knowledge reuse is a marathon topic, and learning rapidly would be the 1,000-foot sprint aspect. And so there's practices that make sense to start with that are easier to do, but then there are practices that are going to have huge benefits long-term for your organization and provide you a competitive advantage that are much more difficult to do. I think Dan had another meeting he had to step away to.
Yes, he had to go, but I don't think there are other questions. So thank you very much. No, there's another question, sorry. Just arrived. What is the best way to introduce knowledge reuse as a practice?
So I'd say there is there's an article at lean.org. It's a coach's corner on knowledge reuse that I wrote. So if you go to lean.org and search my name, you can find it. But the most important thing is to really focus on who's going to use the knowledge. So often when we focus on capturing knowledge, we focus on what's the easiest way to capture it. And then that leads to, we have a lot of knowledge capture, but it's not easy for people to use or find. And so the first step to that really is thinking about how is this knowledge going to be used? And then how do we capture in a way that makes it easier for people to use?
Great, thank you very much. So no more questions this time for good. No, there's another question. How to get people to feel the need to reuse?
Knowledge or
I think knowledge, because it is from
okay.
the same person. Yeah.
So I think the key there is you need to make it easier for their work. So no one likes the idea of generating new knowledge that already exists in the organization, but the reason that is done so frequently is because the knowledge is really hard and painful to find. So it is exciting to generate knowledge. Searching for knowledge in systems that are hard to find knowledge is not nearly as much fun as generating new knowledge. And so you really need to look at that. It is that user of the knowledge, and how do you make this experience better for them? And so if you're in it, I don't think anyone likes the idea of recreating knowledge that already exists. Like, that's not great work. But if finding the knowledge that already exists is really painful work, and that you often search for knowledge and you can't find the right knowledge, it's more rewarding to generate new knowledge. And so you just need to really create systems that enable, that is understanding what is the user, who's the ultimate person that needs to reuse this knowledge, what is their experience, and how do you present the knowledge to them in a way that's usable.
Very interesting. Thank you very much again. They say so multiple paths to find it would help.
Potentially. It's hard to say, out of context, but sometimes multiple paths is helpful. Sometimes it's understanding the work and building it into the system. And so creating design standards where you're just able to access the relevant information at that point in the process can be helpful. Trade-off curves can be very helpful if it's supportive of how people do their work. Databases with just, lessons learned organized by projects is generally not helpful, because people don't know it's not organized around how they would need the knowledge, but that is commonly how knowledge is captured.
Sure. So this time, no more questions. So thank you very much, Katrina, for your presentation. And thank you very much, everyone, for attending, and enjoy the rest of the event. And I'll see you around in other sessions. Bye-bye.